we have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that...
Have you ever wondered what would happen on the day when one company, just one company, suddenly moves far beyond everything the electric vehicle industry has ever known? Not just one step ahead, not just one generation ahead, but so far ahead that every remaining competitor has to sit back and ask themselves, who the hell are we competing with? A few weeks ago, when Elon Musk stood on stage and introduced Tesla's latest electric motor, most people thought it was just another normal technology showcase, a product launch, a few impressive numbers, some applause, and then everything would go back to normal. But no, this time was completely different. Because what Tesla just unveiled is not simply a stronger or lighter motor, it is a complete redefinition of how we understand what an electric motor is, what it can do, and how far it can go. With a carbon fiber sleeve wrapped around the rotor, with a spinning speed beyond 20,000 revolutions per minute, with the ability to accelerate from 0 to 60 miles per hour in less than 2 seconds, Tesla has just pulled the entire EV industry onto a completely new level, and most rivals have not even realized it yet. But here is the part that is truly worth thinking about. Tesla is not hiding the secret. They open the patents to everyone. Any automaker in the world can read them, study them, and try to copy them. So why does that not make Tesla lose its advantage? Why can you know the recipe and still not cook the dish? And more importantly, how will this affect millions of people who are thinking about buying an electric car over the next few years? Can other brands catch up, or are we witnessing the beginning of an era where Tesla becomes the undisputed ruler? Those are the questions we're going to explore in today's video. And I promise you, the deeper we go, the more surprising this story becomes. Before we begin, if you enjoy in-depth analysis videos like this, videos that do not just report the news, but explain why it matters and how it changes everything, hit the subscribe button right now. Elon Musk turns a crazy dream into a global threat. To understand why Tesla's new motor is causing such a shock, we need to step back a little. Not just a few years, almost 20 years. In 2003, when two young engineers named Martin Eberhard and Mark Tarpenning founded Tesla Motors in San Carlos, California, the auto industry saw it as a joke. Electric cars at that time, if they existed at all, looked like golf carts with windows added to them. No real power, no meaningful range, no one truly wanted to drive them on a highway. The idea that electric cars could compete with gasoline cars in performance, design, and driving feel was completely dismissed by industry experts. Nobody believed it. Not a single major automaker wanted to bet on that future. Then Elon Musk appeared. In 2004, when Musk invested in Tesla and became its largest shareholder, he did not just bring money. He brought a completely different way of looking at what electric cars could become. Not cars for environmental activists, not budget-saving vehicles. In Musk's eyes, an electric car had to be the most beautiful, fastest, and most exciting thing you had ever sat in. In 2008, Tesla launched the first Roadster. Built on a Lotus chassis, this car was faster than most gasoline sports cars in its class. It proved one simple but revolutionary thing. An electric motor could produce real power. Not fake power on paper, real power you could feel when you pressed the accelerator and your back was pushed deep into the seat. Then came the Model S in 2012, a luxury sedan with a giant touchscreen, over-the-air software updates, and enough performance to make BMW and Mercedes seriously uncomfortable. After that came the Model X with falcon wing doors, then the more affordable Model 3, which opened the door to the mass market. Then the Model Y, then the Cybertruck, with a look like a broken spaceship. Every product triggered a reaction across the industry. Traditional automakers began rushing to launch their own electric versions. Ford introduced the Mustang Mach-E. GM poured billions of dollars into the Ultium platform. Volkswagen launched the ID series. Hyundai and Kia suddenly became serious names in the EV segment. Many experts at that time started saying that Tesla had already peaked, that its golden age was over, that once the big players truly entered the race, Tesla would no longer be anything special. They were wrong. Because while everyone else was trying to catch up with what Tesla had already done, Tesla was secretly preparing for the next leap. a leap that almost no one in the industry really predicted. But to understand why that leap matters so much, we need to look at the core of the entire story. Inside the motor that is changing the world, when Elon Musk walked out and introduced the new plaid motor with a carbon sleeve, many people's first reaction was, "That sounds cool, but is it really different?" The answer is yes. And the difference goes much deeper than what you can see from the outside. Let's start with the heart of every electric car. The rotor, the spinning part inside the motor that is responsible for turning electrical energy into mechanical motion. In most electric motors today, the rotor's made from copper and steel alloys. These materials have worked well for decades, but they have a very clear physical limit. When rotational speed rises, the centrifugal force acting on the rotor increases exponentially. At a certain threshold, the material begins to deform. More heat is generated, precision drops, and the whole system starts losing efficiency exactly when you need it the most. Tesla solved this problem with a solution that is simple in concept but extremely difficult in execution: wrapping the rotor in carbon fiber. Carbon fiber, the material you see in Formula One cars, aircraft, and space equipment, has a far better stiffness-to-weight ratio than steel. It is lighter, stiffer, and especially much better at handling tensile force at high speed. When Tesla wraps this carbon layer around the rotor, it creates an external compressive pressure known as preload that keeps the rotor structure stable even when it spins at extremely high speeds. The result? Tesla's rotor can go beyond 20,000 revolutions per minute, a number that most conventional electric motors never reach. And that rotational speed directly creates the power and acceleration you feel behind the wheel. That is why the Model S Plaid can reach 60 miles per hour in less than 2 seconds. Until recently, that number only existed in million-dollar hypercars like Bugatti or Koenigsegg. Tesla just put it into a family sedan. But speed is only one part of the picture. The more important part is energy efficiency. Because the rotor is lighter, the motor needs less energy to spin. That means with the same amount of electricity in the battery, the car can travel farther. That means the cooling system does not have to work as hard. That means battery life can be extended. All of these benefits work together and create a positive feedback loop. A more efficient motor, a more durable battery, longer range, and lower operating costs. And there is one more factor that is often overlooked in discussions about performance: thermal stability. In conventional motors, heat is enemy number one. When temperature rises, metal expands unevenly, causing microscopic imbalance inside the motor. Over time, this leads to wear and reduced performance. Tesla's carbon sleeve does not expand in the same way. It maintains consistent compressive pressure no matter how the temperature changes, helping the rotor stay stable under all operating conditions. In other words, this is not just the fastest motor Tesla has ever made. It is also the most durable, the most stable, and the most efficient, all in one design. It may sound simple at first, but this small detail could be the thing that changes the entire game. The secret is hidden where you least expect it. Now, this is the part that truly amazed me when I first read about it. Wrapping carbon fiber around a metal rotor does not sound too complicated in theory, but in reality, this is one of the hardest engineering challenges Tesla has ever faced. Why? Because carbon fiber and metal, especially the copper and steel inside the rotor, have different thermal expansion coefficients. To put it more simply, when the temperature changes, these two materials expand and contract at different speeds. If you simply wrap carbon around the rotor without extremely precise calculations, when the temperature rises during operation, the carbon layer can peel off, crack, or worse, cause severe imbalance at 20,000 revolutions per minute, and you can fully imagine what would happen after that. To solve this problem, Tesla had to build an entirely new robotic system from scratch, controlled by artificial intelligence, capable of applying the carbon layer with micrometer-level precision. Not millimeter, micrometer, meaning 1,000th of a millimeter. This system controls everything at the same time: the tension of the carbon fiber throughout the wrapping, the ambient temperature, the wrapping speed, the angle at which the fiber is applied, and then it verifies the result with laser sensors to make sure there's no deviation at all, even the smallest one. Every rotor is individually inspected before being installed into the motor. This is the key point. Tesla patented this carbon sleeve technology and then opened it to the entire world. Anyone, any company can read the design. But the design is not the machine. You know the secret, but you do not have the machine to execute that secret. You do not have the artificial intelligence system trained through thousands of tests to know exactly how much tension is enough. You do not have the quality verification process refined over years. And even if you had all of that, you would still need to integrate the entire thing into a production line at the scale of tens of thousands of units per month. This is Tesla's genius strategy. Opening patents is not about being generous, it is about showing the gap. They're telling the whole world, we have gone so far that even if you know all our secrets, you still cannot catch up. But no matter how good a technology is, it means nothing if it cannot be produced at scale. The challenges Tesla does not want you to remember. Of course, not everything is perfect. And if we only praise Tesla without looking at the real risks, then this is not honest analysis. So let's speak directly about the challenges Tesla is still facing. First, production cost. Carbon fiber sleeve technology with micrometer level precision is not cheap. Each rotor requires machine time, quality inspection, and expensive materials. While Tesla is rapidly expanding output, the production cost of each Plaid motor is still significantly higher than a conventional motor. This raises a question. Can Tesla bring this technology into mainstream models like the Model 3 or Model Y? Or will it remain a privilege of the high-end segment forever? Second, financial pressure. In 2024, Tesla had to carry out major layoffs and faced questions about shrinking profit margins as the price war with Chinese competitors became increasingly intense. BYD, SAIC, NIO, these names are no longer small startups. They are producing millions of cars at much lower costs, and they are aggressively expanding into international markets. In a price war, better technology does not always win. Third, too much dependence on one individual. Elon Musk is a marketing genius and the strategic mind behind many of Tesla's breakthroughs. But the brand's extremely close connection to him is also a risk. The controversy surrounding Musk on social media platforms, his divisive statements, his promises that were not delivered on time, all of these affect consumer trust in Tesla. And for buyers aged 45 and above, people with enough experience not to be easily swept up by hype, trust matters more than speed. Fourth, charging infrastructure. Tesla's supercharger network is still one of its biggest competitive advantages in the United States, but as Tesla opens superchargers for other brands to use, that advantage becomes less exclusive. At the same time, range anxiety remains a major psychological barrier for many buyers in states without dense charging networks. And fifth, uncertainty around self-driving. Tesla has been promising full self-driving for many years. The technology has made significant progress, but it still has not reached the level Musk once promised. This creates a gap between expectation and reality, and that gap damages credibility. These challenges do not erase what Tesla has achieved with the Plaid motor, but they remind us that in the real business world, the best technology does not automatically lead to market victory. Many other factors have to line up at the same time. And this is exactly where the race becomes even more intense, because Tesla is not the only company trying to dominate the future. The ones who refuse to give up. When Tesla announced the Plaid motor with its carbon sleeve, competitors reacted in many different ways. Some stayed silent, some dismissed its importance, and some quietly accelerated work inside their laboratories. Let's look at each group. Lucid Motors is the most dangerous rival in terms of pure engineering. The Lucid Air Grand Touring performance has a range of more than 500 miles, a number the Tesla Model S still has not reached, and Lucid's drivetrain is designed with an impressive level of technical sophistication. But Lucid is facing a serious problem: sales. They only produce and sell a small number of cars each year, mainly serving the ultra-luxury segment. That is a niche market, not a revolution. And without large enough revenue, there are not enough resources to develop next-generation motors at a scale that can compete with Tesla. Rivian is building something different: electric trucks and SUVs for the outdoor lifestyle. They have good design, loyal customers, and financial support from Amazon. But in terms of pure motor technology, they're still using a more conventional motor architecture, and the gap with Tesla grows wider with every new generation. Ford is the most interesting story among traditional automakers. The F-150 Lightning sold fairly well and proved that Americans are willing to buy electric trucks. But Ford still depends on outside battery and motor suppliers, and it has had to cut EV production targets several times because costs got out of control. With a business model split between gasoline and electric vehicles, Ford cannot bet everything on new motor technology the way Tesla can. GM has poured nearly $35 billion into electrification, but the Ultium platform, once expected to become the foundation of its future, has suffered from delays and real-world deployment problems. The Cadillac Lyriq and Chevrolet Equinox EV are good products, but they have not created any technological wow moment comparable to what Tesla just did. And then there is BYD. This is the name Tesla has to watch most closely. This Chinese company has surpassed Tesla in total global electric vehicle sales. It has a better vertically integrated supply chain than most other automakers, making its own batteries, chips, and many key components. Its production costs are significantly lower, and it is pushing hard into Europe, Latin America, and Southeast Asia. However, BYD still has one important weakness. Its brand and software ecosystem are not strong enough in the United States. American consumers, especially those aged 45 and above, still tend to trust familiar brands more than unfamiliar new names. And until BYD truly enters the American market at a large scale, something blocked by tariffs and trade policy, Tesla still keeps its home field advantage. The key point is this: no rival is truly threatening Tesla on every front at once. Lucid has engineering but lacks scale. BYD has scale but lacks brand strength in America. Ford and GM have brand power but lack both. Meanwhile, Tesla has everything and has now added a motor that no one else can currently copy. So in the end, the biggest question remains: is this technology truly powerful enough to change the future? When an electric car motor goes beyond electric cars, this is the part that makes the story truly big, bigger than any single car or any single race. During the presentation of the new Plaid motor, Elon Musk said something that many people overlooked because they were focused on the performance numbers. He suggested that this motor, with its superior power-to-weight ratio, thermal stability, and ability to run at high speed for long periods, has potential applications far beyond automobiles. Think about electric aviation. One of the biggest barriers for electric aircraft so far has been the propulsion system. The motor has to be light enough not to add too much weight, but powerful and reliable enough to operate safely. Many startups are pursuing electric vertical takeoff and landing aircraft, but they all run into the same problem. Current motors are either too heavy or not efficient enough across the required speed ranges. Tesla's Plaid motor with a carbon sleeve could be the answer. Light, powerful, thermally stable, and capable of operating at high revolutions per minute for long periods without losing performance. These are exactly the qualities the electric aviation industry is looking for. Tesla has not officially announced any plan to license this motor to the aviation industry. But the indirect signals are already fairly clear, and if that happens, Tesla will no longer just be a car manufacturer. It will become a hardware supplier for a full-scale energy revolution. Think about energy infrastructure. Wind turbines, industrial pumps, large-scale energy storage systems, all of them need high-efficiency electric motors that can withstand harsh conditions. If Tesla can mass-produce Plaid motors at a steadily lower cost thanks to economies of scale, it could become the electric motor supplier for the entire clean economy, from vehicles to aircraft to the power grid. This is not science fiction. This is the logical next step for a company that already has gigafactories on 3 continents, produces megapack batteries for national power grids, and operates Powerwall solar energy systems for millions of households. Tesla is no longer just an electric vehicle company. It is becoming an energy and mobility platform for the 21st century. As for the competitors in the auto industry, they are trying to build a good electric car. Tesla is trying to build the infrastructure for a world without fossil fuels. Those are 2 completely different games in scale and vision. And the Roadster 2.0, the electric sports car Tesla has promised many times and repeatedly delayed, could be the final test of everything the Plaid motor can do. If it launches with the performance Tesla promised under 1 second from 0 to 60 miles per hour, more than 600 miles of range, and the full application of the latest motor technology, it will not just be a fast car. It will be the strongest technological statement any car company has ever made. The game is not over, but Tesla is reshaping the game from the beginning, once again. So we have gone through a long journey from the first Roadster in 2008 to the motor wrapped in carbon fiber with micrometer level precision today. But I want to pause for a moment and speak directly to you about the most important thing in everything we have just discussed. Tesla's Plaid motor technology is real. The performance numbers are real. The technical gap between Tesla and its rivals in motor engineering, at least at this moment, is real. But the history of technology has taught us that a technical gap does not always decide who wins the commercial race. Betamax was technically better than VHS, but VHS won. BlackBerry had a physical keyboard better than any touchscreen phone at the time, but the iPhone changed everything. Nokia dominated the phone market for years, then almost vanished overnight. The electric vehicle market is still taking shape. Consumers are becoming smarter. Government policies on EV incentives can change. Battery prices are falling quickly, and that can narrow anyone's cost advantage. And in a shifting geopolitical environment, decisions about supply chains and tariffs can reshape the game in ways no one can predict. So yes, Tesla has just done something incredible with this new Plaid motor. But is this truly the end of the electric vehicle industry as we know it? Are rivals really unable to catch up, or are they secretly developing breakthroughs of their own that we do not know about yet? Honestly, I do not know. And anyone who claims they know the answer for sure, you should be skeptical of them. What I do know for sure is this. What is happening in the electric vehicle industry right now? Fierce competition, technical breakthroughs, price wars, the infrastructure race, all of it is shaping the future of transportation around the world. And what happens in the next 3 to 5 years could decide the shape of this industry for decades to come? What do you think? Has Tesla really ended the game with this new motor? Or can competitors from Lucid to BYD to names we have never even heard of still create surprises? I would love to hear your opinion. Leave a comment below, especially if you own a Tesla or are thinking about buying an electric car. Share your real thoughts. Those are the most valuable perspectives. If this video showed you something new about the electric vehicle revolution, hit like to help this video reach more people. And if you want to keep following deep analysis like this, not just about Tesla, but about the entire picture of technology and energy that is changing the world, subscribe to the channel.